This conference will now be recorded.
Hello everyone. Today's topic will be nomenclature of organic compounds. So we'll start it. First, before going to IUPAC nomenclature, we have to know another term under nomenclature topic, which is common name or trivial name. Fine. So as organic chemistry consists of millions of compounds that we know, which is carbon and hydrogen based compounds, though there may be some heteroatoms, but their numbers are actually very large. So because of this huge number of compounds, we need some proper identification. Just that we all have some specific names. Just like that, molecules also, like us, they also need some names so that we are not confused between different compounds. So there should be a proper identification. And for this proper identification, we also need some systematic method of naming. Because if I am naming a compound in a particular way, someone else is naming it in another way, then there will be some confusion. So there should be some fixed rule based on which we can decide the name, so that the name is fixed for a particular molecule. There cannot be more than one name for a particular molecule. And that is developed by IUPAC. The full form is the International Union of Pure and Applied Chemistry. Okay, so this is the importance and why it is needed. That is the nomenclature for organic compounds, why it is needed. So this is the reason. Now, before the actual IUPAC naming system of, that is the rules that we are going to see, there is actually some other names. So organic compounds were assigned. Why are assigned? That means in past there are some names, and these names are basically based on their origin or certain properties. And it is not based on any specific rules. So without following any specific rules, there is some names. So just for example, if I am saying formic acid, formic acid formula is HC double bond O OH. Now this formic acid, this is actually the trivial name or common name. And how we are getting this name? The name is basically coming from formica, which is a Latin word. Okay, so formica, it is a Latin word, and this formic acid, it is mainly found in ants. So that is why, that is this particular acid, it is found in ants. So that is why the name is formic acid, and the Latin word is source is formica. Then another example is there, which is acetic acid, CH3CO double bond OOH. Now here the Latin origin of this name is acetam. And acetam is basically the name for vinegar. Just like formica, name for ants, acetam is the term used for vinegar. It is a Latin word. And based on that, the name for this molecule, that is the common name that we get, is acetic acid. Okay. So this is the origin of trivial name or common names. So based on their origin or some common property. So these names are called trivial or common names, and in some cases, these names are actually still nowadays, these names are followed. So that is just sometimes instead of using the actual IUPAC name, mostly we are habituated to name this compound, that is CH3COOH, as acetic acid. Though it is not IUPAC based name, it is origin based name, but still its uses are still there. But not in all the molecules, in some cases. They are useful and actually sometimes indispensable. That is, you are bound to use that when, particularly when the alternative naming system, that is the actual rule-based naming system, which is IUPAC name. Suppose based on that the name is very lengthy and complicated. In that case, just for easier, to make it easier, sometimes we use the trivial name or common name. So sometimes it basically becomes indispensable. That is, we have no other way, but we are bound to use it because the IUPAC based name is very lengthy and complicated. Okay, so this is the significance of trivial or common names. Now in the next slide, we will see here in this table, you can see the common names for all these compounds in the left hand side column. So CH4, common name, it is methane. Though this name, it is, if we consider IUPAC based name, then also you will find similarity. But better you consider the other names that is C2H2. Now C2H2 is AC triple bond CH. If we follow IUPAC name, this is actually not the name. Okay, but here we are using the name acetylene. Fine. Then some more examples, as you can see here. Now this one is, there is 2 methyl groups, then carbon, and then CH3. So Me2CH3, we can also write it like this. You can write Me or you can write CH3. So 2CH3, then CH, then CH3. So there is total 4 carbon. Okay. So it is called isobutane. Then neopentane. So with the common carbon, there is total 4 CH3 groups attached. Now this one is formaldehyde. Then we have acetone, that is H3C, C double bond O, CH3. So this molecule, though it is not IUPAC based name, but we are mostly habituated with this name, that is acetone is the common name. In most of the books, you will find this name for this particular molecule. Okay. Then some more examples, as we can see here, there is also ethane molecule, amide molecule. Now some more examples where aromatic ring also you will find. So see here, if we consider this one, this we have just discussed in the previous slide, that is acetic acid. Then if you consider this one, it is toluene, C6H5CH3. This is actually benzene, and with that we have CH3 groups. So here total number of carbon, that is if you simply consider benzene ring, for benzene ring it is C6H5, C6H6, but as we have replaced one hydrogen with methyl group, so that is why now it is C6H5, and instead of another hydrogen, now we will have CH3. So for this particular molecule, we have the common name toluene. Then we have aniline. So just in place of CH3, if we have NH2, then this molecule is called aniline. Then we have phenol. Now OH group is attached to this. Then we have anisole. So see, keeping the benzene ring fixed, we are just changing the substituent, single substituent. This is known as anisole, OCH3. Then acetophenone. So acetophenone is C double bond O, CH3, and it is attached to benzene ring. Then we have benzamide. Benzamide is this one. Now amide group, that is CONH2 group, that will be present in the benzene ring. So these are the some common or trivial names for different organic compounds. Next we will start the actual IUPAC nomenclature. So according to this IUPAC recommendation, to name any organic compound, we always consider it as a derivative of its parent saturated hydrocarbon, or the parent hydrocarbon may be, there may be some unsaturated. So it is always based on the parent. Fine. Just take the example of methane. Methane is CH4. It is simply hydrocarbon. It is the simplest hydrocarbon possible, because minimum carbon we have 1 and tetravalency is satisfied. So this is hydrocarbon, the simplest hydrocarbon. But suppose we have one hydrogen replaced with some halogen or OH group or NH2. So what we will have, suppose if it is NH2, then now we will have amine CH3NH2. But remember here, this CH3NH2, it is actually the derivative of this CH4, as if you have replaced one carbon hydrogen bond with carbon NH2 bond. So that is why it is derivative of CH4. So this is the basis of IUPAC nomenclature. The most important feature of this system is that any given molecular structure has only one IUPAC name. So one particular molecule cannot have more than one name. Otherwise, it will be very, it will create some confusion. Okay, so that is why only one name for one molecule. And when there is any name, that is in reverse order, if you consider any name, suppose I am telling you one name for a particular organic compound, then you will draw the structure. You can draw only one structure. It is not that I am saying a particular name and you can draw from this name 3 to 4 structures. No, it is not like that. You can draw only one structure. When the name is given, you are drawing the structure, or the reverse way. That is, you already have the structure, and now you are writing the name. Whatever you do, it is always 1 1. Fine. The IUPAC name of an organic compound, how we will start? Remember, there will be a prefix. Now, prefix, the term itself means something which is pre. So, if you consider this is the middle point, that is root word. If it is the middle point, then first, that is in pre of root word is prefix. So that is why the term we are saying using is prefix, and the terms that will come after the root word we will call them suffix. Now under prefix there is secondary suffix. Under prefix there will be 1 degree, 2 degree, two types of prefix. You can also call it primary or secondary. 1 degree means primary, 2 degree means secondary. And for suffix also there will be two types, that is 1 degree or 2 degree. Fine. So what is root word? First we'll see the middle point, which is root word. So it denotes the total number of carbons in, not total number of carbons in the molecule, total number of carbons in the longest continuous chain of carbon atoms. And this longest continuous chain, it must include the functional group if present. Suppose functional group is not present, that is fine. But if it is present, it must contain the longest continuous chain that you are choosing. It must contain the functional group. And sometimes there may not be functional group. Suppose we have some CC multiple bond, triple bond or double bond. Then that bond should also be present in the longest continuous chain. And in that longest continuous chain, you have to count the total number of carbon, and based on that, you have to select the root word. So remember, functional group, multiple bonds, this must be present. If it is not present, it is okay. But if it is present, you must choose the longest chain in such a way so that there is presence of functional group or multiple bonds. Now, depending on the number of carbon, minimum is carbon 1. And for that, we use the root word neet. Just remember the name methane. So how it is changing from neet to methane, we'll come to that point. But right now, this term is, we have already heard it in case of the molecule CH4, we call it as methane. So here we have only one carbon, so that is why the root word is meth, M-E-T-H. And in each of these name root word, you can see hyphen. That means it will be continued. It is not that you only use meth, eth, prop, not. It is not like that. There will be something else that will add. So that is why there is a hyphen sign. But we have to remember all these terms. So when there is one carbon, we will use the root word meth, then eth, prop, but, pent, hex. So until 12 carbon, you can see this table, and this will be enough because mostly you will have molecule where longest chain, it will not cross 12. Okay. So C7, it is hept, oct, non, dec, undec, and dodec. Okay. So this is root word. Next, we have to know suffix. So this IUPAC name, as we have seen, total 3 parts. Root word, you can also put it in the middle. It doesn't matter. Basically, it is prefix, then root word, then suffix. Because prefix, it will come before the root word, and suffix, it will come after. Okay. Now, under suffix, there will be 1 degree suffix or 2 degree suffix, that is primary or secondary. Similarly, for prefix also, there may be 1 degree or there may be 2 degree prefix. Though the use of suffix, that is this division under suffix that you are seeing, that is most common, but for prefix also 2 possibilities are there. Okay. Now this suffix, which is, it may be 1 degree or 2 degree, this 1 degree, how to choose it? It is basically the nature of the carbon chain. And the 2 degree, that is based on the functional group. Now this functional group, it may be OH group, it may be NH2, it may be any halogen. So that is all about the secondary suffix. What functional group you have? Functional group we have already seen in the previous class. And primary suffix, that is based on the nature of carbon. Because sometimes the nature of carbon, it may be saturated, or sometimes it may be unsaturated, right? That is CC triple bond or double bond may be there. or there may not be any double or triple bond. It is simply carbon-carbon single bond. So that is the nature of carbon chain. Fine. So first we will see details of suffix. So it denotes the functional group and is placed after the root word. Fine. And there are two types of suffix, and it has to be after the root word because that is why you are calling it suffix. Now it may be two types as we have seen in this flowchart, primary or secondary. Now what is primary? That is based on nature of carbon chain. So primary suffix is denoting whether there is any saturation or unsaturation present in the molecule, and it is added immediately after the root word. So here in this table you can see primary suffix for different types of saturated and unsaturated. Unsaturated means double bond or triple bond, any of these two are present. So when it is saturated, the primary suffix is N. Remember, in case of one carbon, the root word is neet. Now just after the root word neet, if you add N, you are getting the molecule CH4. So in this way, you are combining the root word and the primary suffix N, you are getting the name of the molecule CH4, which is methane. If it is unsaturated, now when it is unsaturated and suppose there is only single C double bond O, then it is simply ENE. Here it is ANE, here it is ENE. Okay. Now suppose I am saying the root word is eth, that is 2 carbon, and there is double bond, 1 double bond. So the simplest example is the detailed orbital diagram of this molecule we have already seen. So it will be ethene because you have 2 carbons, so the root word is eth, and it will be combined with the term ENE, which is primary suffix because we have only one CC double bond in this molecule. If it is 2 CC double bond, it will be simply diene. Just like that, if there is 3 CC double bond, it will be triene. Now come to triple bond. Suppose there is 1 triple bond. Then the term we are using now YNE. If 2 triple bond, diene. So take the example of this one, where we have 2 carbon and 1 CC triple bond. So we should use the root word eth, and after that YNE. So this molecule must be ethyne. Fine. So this is primary suffix. Now some examples we are going to see here. So in these examples, basically we will see how to use the root word or word root, and along with how to attach the primary suffix. So see, in this molecule we have total 4 carbon. We do not have any double or triple bond. So root word is but because we have total 4 carbon atoms. And primary suffix is N because we have only CC single bond. Just add these two terms. What you will get? You will get butane. Similarly, the second example, we have total 3 carbon, but we have CC double bond, 1 CC double bond. So for 3 carbon, it must be prop, and for CC double bond, 1 CC double bond is there. We are using the primary suffix in, so just add these two terms, it will be propene. Come to the next example, total 4 carbon. Fine, so it is but, but we have total 2 CC double. So it is diene. So but and diene. So butadiene. Now here extra A we have to add, and because if you are saying diene, it is not correct. So here one extra A we are adding. Okay. Then we have the fourth example, which is 2 carbon. So eth. So this example I have just discussed. It is ethyne. Again, we have the fifth example, 1, 2, 3, 4, total 4 carbon. So the longest chain Here you can easily recognize the longest chain. It is not very difficult. So total 4 carbons, so it is but, but there is total 2 CC triple bond. So diene, but you have to add this extra A. Fine. So here in this slide we have learned how to combine the root word or word root with the primary suffix. Okay. What about the secondary suffix? Now this is very important because so many variety you are going to see. As we know, there are different types of functional group, and based on that we can have different terms for different functional group we will use as secondary suffix. So see very carefully, it is used to denote functional group present in the organic compound, and it is not that you will have always one functional group. You can have more than one functional. If it is one functional group, it is okay. It is easier. But when you have two functional group, what you have to do? 2 or 3 or 4. So when there is more than one, what we have to do? We have to give one particular functional group more preference. That is, more priority it will get. So the functional group that is getting the higher priority, that should be considered as the principal functional group. Okay. And the rest of the functional group, they are not principal functional group. So depending on, suppose you have total 3 functional group, and among these 3 functional group, one particular group is principal. Suppose we have X, Y, and Z. Now Y is principal functional group. These two are not. So we have to first select this principal functional group, because when it is principal functional group, the secondary suffix, the term that we are going to use for this Y, and when Y is not principal functional group, then the term that we are going to use, these two are not same. So that is, it is important to understand which group you are giving higher priority. So the remaining functional group, so in this case X and Z, these two are remaining functional group with lower priority. So they are having lower priority compared to Y, or you can also call them subordinate functional group. They will be treated not as functional group, now as if they are simply substituent. And for those, we will use some prefix. But what is prefix? That we will discuss separately. But as these two are related, so whenever we are choosing one particular functional group as principal functional group, rest of the substituents, they are no longer suffix. Okay. If it is single functional group, it is okay. But if it is more than one, then you have to choose first which group you are going to give higher priority. And there are rules for that also. And rest of the functional groups, they will be treated as lower priority. And they are now treated as substituent, indicated by prefix. So in this table, we have to look at it very carefully. Here, look at the heading, what it is saying. First of all, class of organic compounds. When you have this functional group, suppose you have functional group CO2H. This is nothing but CO2H. So when you have CO2H, the class of compounds, this we have already seen. That is the corresponding class of compounds. It is actually carboxylic acid. But this column is not important here. You have to just understand these names. So see, in the third column, it is mentioned as secondary suffix. In the fourth column also it is mentioned as secondary suffix, but try to understand the difference. This term you will use, that is oic acid, when the functional group is part of parent chain, but that may not be always, especially in case of cyclic compounds. So when carbon of the functional group is not part of parent chain, I am not saying that this is lower priority group. It is still the high priority group, but still it is not part of the parent chain. Now, if you are thinking that we have already mentioned the rule, when we will choose the longest parent chain, it must contain the functional group. Then how it is possible that now they are not part of functional group? Actually, it happens only when you have cyclic compounds. So when it is cyclic compounds, you just have to count the number of carbon in this ring, which is 5. But here you cannot place CO2H group. It will be always be like that. So in these special cases, so this fourth column, this is actually special cases. You will not mostly you will not find it, but still you should know, especially in case of cyclic compounds. So CO2H, if it is part of the, that is, suppose this is a parent chain and you have this CO2H. Now this is 1, 2, 3, 4, 5. Okay. So you are counting the carbon of CO2H. It is part of the parent chain. But in the second case, it is not part of the parent chain. So in the second case, you will use this carboxylic acid term, but oic acid you will use in the first case. Number 1, number 2. So this is number 1, you will use. Number 2 case, you will use this one. Fine. And when they are used as prefix, though prefix we have not discussed, but we have to use it here, because what happens, suppose CO2H group, when it is not treated as main functional group, then what to do? Suppose it is prefix, which is mentioned here, lower priority, it is prefix. So in that case, this is the term that is used. Next group, acid anhydride. Oxygen, and both sides we have some C double bond O, and these two sides there will be some other R group, that is carbon hydrogen substitutes. So it is now weak anhydride, but if they are not part of the parent chain, it is carboxylic anhydride. And they are not used as prefix because actually it is difficult to make you understand right now why they are not used prefix. The more examples you will see, more rules you will learn, it will be gradually clear that why it cannot be used as prefix. Fine. Because one simple way I can say that, as here both side there is some substituents, there is some carbon hydrogen part must be there both side. But see, if you look at the other functional group, it is mono, only one side there is group. So it cannot be present as a substituent. That is, this point if you consider, it cannot be present as substituent, because for to present as substituent, it must be attached only at one position, but it is attached from two sides. The group is such that it should be attached from both sides, but that is not possible. So that is, it cannot be substituted. Okay. Then we have ester, which is just like the first one, only difference. Now you have some OR group, not OH group. So now it is treated as alkyl weight. Now this alkyl is based on this R prime. Suppose R prime is CH2CH3, then it will be ethyl, and they use weight. So suppose in this side we have methyl group, so it will be ethyl. This is ethyl, R prime 2 carbon, and here also we have 2 carbons. It will be ethyl ethanoate. Fine. But for general, as we are mentioning it as in a general way, so that is what is written as alkyl weight. So alkyl term is for this particular group. Then alkyl carboxylate, when it is not part of the parent chain, and when it is treated as substituent, which is nothing but prefix, then it is alkoxycarbonate. Fine. So alkoxy is for this part, OR prime, and carbonyl is for C double bond O part. Acid halide. Now instead of OR prime we have X, so it will be called as oil halide. Okay. So suppose here if we have methyl group at this position, so total number of carbon, it is 2 carbon, so it will be ethanoyl halide. But if it is not part of the chain, it is carbonyl halide. So whenever it is not part of the chain, we are using some carbon term. Just see here we have used carboxylic, and here we are using carbonyl. So it is not, you are not counting that carbon when you are counting the total number of carbon in the parent chain. Actually here it is not chain, it is ring. But total number of carbon when you are counting, you are not counting this CO2H. So that is why it is treated as if it is separate. But still it is secondary suffix. Next we will see some more examples. CONH2. So it is the functional group. We know it is amide. But if it is not part of the chain, then it will be carboxamide. So just like that, we have so many other groups. It is basically aldehyde. We call it Al, but when it is not part of the ring, sorry, a parent chain, or you can say it is a ring compound. Cyclic compounds mostly it is applicable. Then carboxamide, carbonyl, carbaldehyde. Ketone. This is also a very common functional group. We use on. Okay. Now in this case, secondary suffix is not possible because as you see, both sides there should be some substituents, right? So it cannot be outside the ring. Both sides you have to place some group. So that is it cannot be outside the ring. And when it is treated as prefix, sorry, one thing I forgot to mention. This point is very important here. Decreasing order of priority. That means CO2H group that will get more priority than this anhydride. Then anhydride will get more priority than ester. So as we are moving down in this table, gradually the priority is decreasing. So that is it is mentioned in blue color, decreasing order of priority. Okay. So here also it is just like that. Alcohol, it is OH, we use all. SH, which is just like OH because oxygen sulfur they are from same group, group 16. So it is just like that, all, but slight difference, it is thiol. And when it is used as prefix, it is hydroxy. That is when, suppose you have two functional group, you have aldehyde, you also have OH. Then what you will do, both these groups suppose present in the molecule. So these will be treated as principal and these will be treated as substituents. So now you cannot use the term all. You have to use L because now this is the main functional group and OH is now subordinate. So you have to use hydroxy. You cannot use OL. Okay. So in this way, some more examples we are going to see. So it is decreasing order of priority. So as we are moving down, gradually the priority is decreasing. So it is amine, it is imine. Now imine, it is also, you can find similarity with ketone. So in case of ketone, you have C double bond O, but now instead of O, you will have NH. That is the difference. So it is imine. Look at the spelling. It is amine, A-M-I-N-E. It is I-M-I-N-E, imine. Then for CC double bond, we know it is in and it is wine. Now these two, they are at the last position. So you have to give more priority all these functional groups, and then these are coming at the last position. Okay, and they are never treated as substituents because in the longest parent chain you consider them. So that is why we do not have any term for this as prefix. Okay. So the secondary suffix, it will be added to primary suffix. Remember the primary suffix, when it is saturated, it is N. When it is unsaturated, it is either in or YNE. So this is all about 1 degree suffix. But secondary suffix or 2 degree suffix, it is all about the functional group. So now you have to add this to this 1 degree suffix. So now you are basically combining 1 degree suffix and 2 degree suffix. But we have to keep this fact in mind. By omitting its terminal E, if the secondary suffix begins with a vowel. So secondary suffix, remember we have just seen when there is OH group, it is treated as OL, just like OL. So it is vowel. So when it is vowel, then this terminal E, and when it is consonant, just like nitrile, that is C triple bond N, this group. Okay. So when it is consonant, it will be retained. But when it is vowel, you have to omit it. This is the difference. So here are some examples if we see. The first compound, total 4 carbon. 3 carbon. So here the root word that we will use is prop. Now with this root word, the next it is alkane, that is N. We do not have any double bond. So it must be ANE. And then the functional group, only one functional group we have, so it is amine. but it is starting with A. So you have to omit this E. The name should be propanamine. So this E will not be used. Simply you will add rest of the terms, omitting this E. It will be propanamine. Next molecule, total 2 carbon. So I will use the root word eth. There is no CC double or triple bond. It is again N. We have OH group, so it is all. So you have to omit this E. So it will be ethanol. Come to the third one. Total number of carbon 3, because now you have to consider this carbon when you are considering the total number of carbon. So prop, we do not have any CC double or triple bond. So again it is N and nitrile. Fine. So one point I would like to mention here. So see, these two are actually very different. When it is main function is nitrile, when it will be substituent, it is completely different name. It is cyano. Be careful, okay? So propanenitrile. Now here we have consonant. We do not have vowel. So that is why this E you have to retain. You cannot omit it. So the name will be, after at combining all these terms, propanamine. Propanenitrile. We will pronounce it in this way, propanenitrile. The E is retained. Come to the fourth example. Total number of carbon is 3. So I will write here prop. We have double bond, CC double bond. So ENE. Then we have CHO group. So here also you have to count all the 3 carbon. Don't forget the carbon of CHO. That also should be treated in the root word. So that is what is total 3 carbon. It is prop and it is L. Now, as it is vowel, you have to omit this E. So it will be propanal. No E will be there. The next example, total number of carbon 1, 2, 3. Again prop. Now it will be YNE because we have triple bond. And this one is oic acid, remember? So it is oic acid. So it will be, it is starting with vowel. That means E will be omitted. So cross, here it will retain. The rest of the 4 examples, it will not be there. So it will be propanoic acid. Now see all these that we have just done. Prop, it will be prop. So all these 3 are prop. N. The last 4th one is in, then YNE. This one is amine, then all, then nitrile. This is L. So this one is only where it is constant, consonant. Rest of this, they are vowel. So see the name, there is no E. No E. Same. E is retained. Here it is present. In this case, propene, there is no E. Isn't it? Then propyl, noic acid. After N, just directly add the oic acid. So there also no E. Only the middle one, that is nitrile, it is retained. Okay. So remember this one. When you are attaching the 1 degree suffix with 2 degree suffix, then you have to remember this fact. Fine. Now come to prefix. Though some terms we have already seen when the groups are used as secondary or subordinate. Now under prefix also there are 2 types, primary and secondary. Though the secondary will be mostly used, primary it is used only in some special cases where it is a cyclo or ring compound. So primary prefix, sometimes it is also known by these terms. So this is used simply to distinguish cyclic compounds from acyclic compounds. And for cyclic compounds, there is some special terms used, though spiro, bicyclo, these are for this our syllabus. It is not details not required. Simply the cyclo will be enough. So bicyclo means when you have two cyclic rings together. Suppose I am writing this 6-member ring and it is attached with a 5-member ring. So it will be bicyclo. Then what about spiral? Spiral means when these two rings are directly connected. So the same 6-member rings I am again drawing, but now this CC bond, it is not present. Directly the 5-member ring is attached. So see this middle carbon, the joining point, it is actually attached with 4 carbons. There is no carbon hydrogen. Here you will find carbon hydrogen bond, but in this case there is none. So this is known as spiral. So cyclo, spido, bicyclo, these terms we use at the starting of that is just when you are writing the name, at the first position it will be used. So that is why it is primary prefix. Prefix means it will be always before root word. And when it is 1 degree prefix, it will be at first position. But it is only for cyclic compounds. Okay. So this will be added between the prefixes and the root word. Okay. So prefixes and root word means it is talking about the 2 degree prefix. So first 1 degree prefix if it is present, if it is cyclic, otherwise no question of it. And then there will be secondary prefix and there will be, it is in between prefix and root word. That means if you have some substituents in the cyclic compound, suppose I have these cyclic compounds and there is some substituents like this, then these substituents, that will be 2 degree prefix. There will be another main functional group, but this is the second subordinate functional group. So now this is secondary prefix. But you also have to use cyclo because it is cyclic compound which is 1 degree prefix. So try to understand difference. Okay. So it is the cyclo, spido, bicyclo, they are added between prefixes and root word. So first we write the substituents, then this cyclo, that is 1 degree, then root word. So that is why it is in the middle position of prefix, 2 degree prefix and root word. So that is it is written in this to indicate the nature of parent chain. Okay. So this particular example that you are seeing, I have chosen it so that we can apply whatever we have learned until this point. Okay. So in this molecule, we can apply all the rules that we have already learned. Fine. Now this is cyclic compound. That is sure. So we have to use cyclo. So this is 1 degree prefix. Here we have Cl, we also have CO2H. But 4-chloro, CO2H is having more priority compared to Cl. So that will be treated as functional group and this will be treated as substituents. Now substituents we know it is 2 degree prefix, right? So we will use 4-chloro because it is present at 4 position. Numbering will start from that carbon with which the main functional group is attached. In this case, it is CO2H. Don't start numbering from carbon of CO2H. That you can do in acyclic compounds, but for cyclic compounds, you have to start it like this. So 4-chloro, this is actually 2 degree prefix. Now here total number of carbon in this numbering, it is hex. So hex is here root word. Now, what about the suffix? It is this molecule, there is no CC double or triple bond. So we have to use N. So this is suffix, but what type of suffix? 1 degree suffix. Now, the actual functional group, which is CO2H, for which we have to use 2 degree suffix. But remember, it is not part of the functional group. I will like to show this slide where we have seen when it is not part of the functional group, we use carboxylic acid, not oic acid. If it is like this, you have to use oic acid. But now for cyclic compound, it is true it is secondary suffix, but still it is not part of the parent chain. So that is why here one position carboxylic acid. This is our 2° suffix. So we have used all the terms that we have learned until now. We have used 1° prefix, 2° prefix, root word, then 1° suffix, 2° suffix. Now we will combine all these 5 factors together so that we can get the name. So the name will be, we will start from 2° prefix, because see, it is mentioned these cyclos, pyro, bicyclo, they are added between prefixes and root word. That means between 1° prefix and root word. Okay. Sorry, it is 2°. So first 2° prefix 4-chloro. So 2° prefix is done. After this 2° prefix, another hyphen. Now it is cyclo. Now after this cyclo, there will be no hyphen. Now it will be treated as a single name. Cyclo, hex, and N. Combine these two. Okay, done. Now hyphen again. We will write 1-carboxylic acid. Now after carboxylic, you have to give gap because these two are not same word. Carboxylic gap acid. So again, if we see, this part is 2° prefix. This part is 1° prefix. This part is root word. So see, 1° prefix is in between 2° prefix and root word, which is mentioned here. N is 1° suffix. And this one is 2° suffix. So I hope it is now clear how we are getting that is all these terms together, and we have also seen the use of all these terms. Though if it is not cyclic, you will hardly use this. Actually, you will not use this 1° prefix. It is simply specifically for cyclic compounds. Fine. Now secondary prefix. This is the only term left. Though we have already seen the use of it. Here you have already used it. Now we will see it in detail. So it is used before the root word. That is why it is prefix. It has to be before the root word to indicate side chain. Or side chain means if there is any alkyl side chain. Suppose you have ethyl group. This is ethyl group. Or you have methyl group. Or you have 3-carbon propyl. Or you have 3-carbon like this. This is called isopropyl. This is also 3-carbon. This is also 3-carbon. But the difference is this is at a stage the chain is going on, but here we have this type of format, which is 3-carbon, but this is isopropyl. It is not simple propyl. So it is used before the word root to indicate side chain. Here you can see 4 side chains I have drawn, and it may be substituents and low priority functional group. So for all these cases where it is in a single word, we can say when you have some substituents, then we have to use secondary prefix. If the functional groups are not part of the parent chain, then also they will be treated as substituents. So sometimes functional groups are not part of the chain, though in that case we have already seen in case of cyclic compounds, but there are some special cases where you will see it is not cyclic compounds, but still the functional group are not part of the parent chain. So there are some special cases. Okay. So in that case, it will be treated as substituents. Only when it will be treated as main functional group if it is part of the parent chain. But sometimes it may not be part of the parent chain, and mostly in cyclic compounds, but in some cases it may be acyclic also. So here we have different substituents. Now this we have the previous table that we have seen, where the same group, when it is used as substituents, we have already seen some of the names, right? So I'm talking about this table. Remember, in this case, we have already seen when the same group, suppose CONH2, if it is not the main functional group, if it is a secondary group, subordinate, then we use carbon 1. But some extra examples we are going to see in this slide, which you will not find in this table. So don't think it is any repetition. So here we have completely different terms. So these terms are mainly used as substituents. Fine. And fluoro, chloro, bromo, iodo. So all these are basically halo. Nitro, nitroso. This is NO, this is NO2 and diazo. Sometimes it is also written like this. Now come to the next one, again side chain of substituents. So when it is OCH3, it is methoxy. When it is OET or basically OCH2CH3, it is ethoxy. Now until this point, it is fine. Now see, as I have said, suppose this is the connection point and you have total 3 carbon, 1, 2, 3. This is also connection point, but now you have these 3 carbons like this. In this case, you will use the term isopropyl, or it can also be mentioned as 2-propyl because the connection point is at 2 carbon. So see the difference. This is also 3 carbon. This is also 3 carbon. But the terms are not same. This is simply propyl. But now it is isopropyl or you can say 2-propyl. Next we have 3 CH3 attached to single carbon. Now it is 4 carbon obviously. Now for normal 4 carbon you use butyl. Suppose normal 4 carbon at a stage 1, 2, 3, 4. In this case also 4 carbon but with branching. So in this case what we will do, we will use this term which is tertiary butyl. If it is at a straight line, then it will be called butyl. But in this case it is tertiary butyl. Next, let me erase it. 1, 2, 3, 4. So we have now CH2, CH. So total number of carbon, again 4, right? But see, when the connection point, it is with single carbon, you have 4 methyl substituents, 1, 2, 3. Then it is tertiary butyl. But if the group branching is like this, it will be called as isobutyl. Okay, or 2-methyl propyl, because if you number it at 2 position there is methyl, so that is why 2-methyl propyl. But better for simplification, isobutyl term is better. But sometimes if you find this one 2-methyl propyl, that is also actually isobutyl. Then the next one, this is also total number of carbon here is 4. But see, now the CH3, it is attached to the first carbon. If this is the connection point, this is 1, this is 2, this is 3, as if this one is attached. So that is why now it is secondary butyl, or you can say 1-methyl propyl. 1-methyl in bracket because it is substituent. It is true that this whole group is substituent, but as if within substituent you have another substituent. So that is why this is whole group substituent, but within substituent you have this substituent. So that is, it is 1-methyl. So this methyl, it is attached at 1 position, but in the previous case it is attached as 2 positions. So that is why the terms are different. So let me. So how we will write secondary butyl? CH3, CH2, CH2. So this is attached at 1 position. But suppose if it is attached at 2 position, now it will be isobutyl. So this is the difference between isobutyl and secondary butyl. So we have to end the session here because, okay, one more point just to mention. Consider it as if it is a note, important note. Alkyl groups along with halo, nitro, alkoxy. Alkyl group means it may be ethyl, methyl, isobutyl, tertiary butyl, only carbon, hydrogen. Also halo, nitro, alkoxy, that means OR group, oxygen then alkyl. Now they are having same preference. Halo, alkyl, that is R, then halo, then nitro, then OR, alkoxy. All these four are having same preference, and they will also have lower priority than even the double and triple. Okay, so this point we have to keep in mind. We will not start any more things, so we will have to end the session here. Okay, thank you for listening.